Hello, this is your internet friend Robert Gadarian. Today I'm going to blow a lot of people's minds because we're going to take programming and flip it on its head. This is called functional programming. There's probably about 4 of you that are watching this that are going to jam on it. The rest of you are going to be confused why it exists. This is part of the Instructor's Choice Week. This is not testable material. You are free to use it on the exam. It's rad. I choose this. This and Pandas, I think, are amazing tools that you should know about. So, what you've seen to date is procedural programming. There's a process that goes through and it does magic for us, and it's great. And we've written functions and we call them once, and it's great. But what we want now is the idea that we have a list of data and we want to apply a function to every item in a list. But Rob, that sounds like a for loop with more steps. Maybe. So let's look at this. We have a function, and I don't know why I didn't put this into my spider already. And we have a list, and we want the squared value of everything in that list. Now, this is a very simple example of what we want to do. The trick here is map. Map is the function that we want to use that will actually run everything for us. And it's called a mapping. The input maps to the output. This is actually another database term. I don't know if you saw the Pandas stuff and all the databasey stuff there. This is actually very similar. This is func school. A square is x times x. I don't think that's going to surprise anyone here. But to do our calculation, we're going to say map this function and give it this data. And it will do it. And we can see our squares down here. Okay. That's neat. It's very short, handy, and it's kind of pretty. That's nice. It's actually a nice thing. Rob, I could have done it in a for loop. That's true. What does a for loop give us that this doesn't? A for loop gives us the idea of order. It will go through our list in order. But do I care about my order if I'm applying square to each one of these elements? No. I could, hypothetically, run each of these at the same time because I don't care about order. The output of me running a square on this one has no impact to the output of me running square on 2, which has no impact to when I run square on 3, which has no impact when I run square on 4. Well, that's interesting. Does that change things for us? Okay. Some people have seen Lambda functions already. They are actually functional programming tools. And that's why I was like, you don't know what you're doing. I saw you use them because they are pretty neat, shorthand ways of writing functional programming. So the idea is that Lambda is an unnamed function. And that, I'll take this out. We can give it a list, and this is a list, arguably. And we are going to map, instead of giving it a function name, I'm going to say this is the entirety of my function. So for each value in nums, put it into x and square it. Whatever the result is, that's going to be my output array. So my output array is always the same length as my input array. And the mapping is between those two things. So element 0 will go through some function, and the result will be stored in element 0 of my output array. And I guess I could actually give this x too, so I can see that indeed I get the same values. Neat. But I've already kind of tipped my hand. Oh yeah, you can do this with Pandas. It's kind of cool. If we have problems that are trivially parallelizable, we could run them all at the same time. The computer that you're staring at right now probably has more than one core. And when we run a Python program, it will only ever use one of those cores. We're missing out on a lot of computer. So why don't we use them all? So I'm going to fire up my activity monitor here. And I'm going to shrink it because it's huge. I'm going to go to CPU. And here's everything that's running. And I apparently made my process name huge. And I can see my CPU percentage. So if I wrote a huge for loop in here, while true, sum total is equal to 0, total plus equals 1. If I run this, it will show up on my activity monitor as Python. It's probably tiny for you. I apologize. I can't increase this font size. And it is using 6% of my CPU right now, which isn't very much. Now 4%, and it's dropping. Oh, Python 3.8. That's probably it. It's using, wow, it's actually using 90% of my CPU. I'm impressed. I was expecting it to only go up to 50. But, oh, it's got threads. It's threading this for me. Oh, it is actually doing some fancy pants stuff for me. That's interesting. It shouldn't be. Oh, the CPU time is 2 minutes. Wild. I bet this is my process. I don't know. I don't know which one is mine now. That's more difficult than I expected. But the problem is that it's still doing it in order. We can tell our computer in a very specific way to do things differently. To run things in no particular order, no known order. This is like dictionaries. Like there's no known order, but we can work with it. I'll have to. Yeah, I'll save this as sleepy time. And what this is doing is that the first one sleeps for a second, the second one sleeps for 2 seconds, the third one sleeps for 3 seconds, up to 9. And I have a multiprocessing pool. And all I have to do to use my pool and all my cores is to map my function and say, call this function on all this data, and each of those can run in its own thread and therefore in its own core. The result is going to be a list, which is the mapping, and will be stored. I'm just going to print it out, but I could store it. I need to import time. I was going to charge out of importing time. I'm not going to lie to you. So it should go 5, 4, 3, 2, 1, 0, and now it should be finished because it ran them all in the same order, and it's complaining to me because it knows that I'm doing nothing. So that is unhappy with me. So multiprocessing, what does that mean? Running many processes at a time. A thread is something that we can run on one of our cores. And a pool is a bunch of these threads, and we can set how many threads it has. We can say fix it to 5 because we don't always, if we had 1,000 things in the list, we probably don't want 1,000 threads. So that's not going to work well for a processor. We usually want to have approximately 2 more threads than the number of processors we have, which is interesting. And a processor is your actual working, if somebody says CPU and talking about computer, they're actually wrong. That is the central processing unit, the actual chip that does the math. So is this real life? Yeah. Apache Spark is something that I've used lots, and it runs across a cluster. So n machines, and you can fork this problem off into all those machines. So you don't only have separate threads, separate cores, you have separate processors on separate computers, all doing the same work, and then collecting one output at the end of it, which is amazing. So, in theory, what is this doing? Oh, this is so grumpy with me. I haven't actually run this in 3.8. Eek. So I want to have a multiprocessing pool, and I wrote a function here in func that estimates pi. Okay, cool. I like it. So I'm going to just paste all this. I don't need this. I do need math, and I do need all, and I'll take this and copy it down here. So I have a process that estimates pi, and I pass it how many iterations I want it to do. So if I run this, it's going to take 3, 2, okay, let's try that again. 1, 2. So about a second and a half. But I want to run this many times, and I want to see how close to pi I can get. And you can see here it's already to this digit, which is really good. So somewhere in the range of about 7 in. It's good. It's a good estimation. So I'm going to make myself a list. So I'm going to say iterations. And I'm going to start at this. I'm going to have a range. Start at that number. End at that with 2 more zeros, 1 more zero. And step by that number. Range is fun. And those are going to be my inputs. That is what's going to be popped into here. And this is the Leibniz formula for calculating pi by 4, which is something I stole off the internet, but I wrote this code myself. Now, I want my multiprocessing pool. So I need a pool, and I need to run this through with my pool. So I'm going to catch this as a list. Of course, I might even need to change that. This is one of the few times I actually want to see the documentation here. Save. Nope. Oh, of course. The one time I actually wanted to pop something up, it doesn't do it. I think I can just paste this. Oh, Spider is unhappy with me today. Oh, I can't even click there? Wow. Okay, she's done. I'm going to call this my inputs. And I want to do a thing. I want to estimate pi by 4 for all my inputs. There we go. That's why I was complaining with me. I'm going to put my inputs here. So what number is this? 10 million took about a second. So if I do 20 million, it's going to take 2 seconds. But I can calculate all of these. And why are you so unhappy? Okay. There we go. And it should only take 9 seconds to do because it's going to max out my entire processor. Oops. There we go. Let's actually look at our pool. I want this to help me. Help me. That's fine. I'm just going to play. And then it'll print out a whole bunch of errors. I need to figure out why there's errors. But it should give me a result in 10 seconds. I can pause this. If need be, 5, 4, 3, 2, 1. Oh, I saw some results. And then unfortunately it stopped. But that's okay. This did use my entire CPU to do this, which is kind of incredible. And my computer fan is running now. And it's pretty trivial. All you have to say is give me a pool and then map. Here's a function I want to run many times, but it has to be trivially parallelizable. So the output of one is not needed for the input of the other. And it's pretty cool. I'm going to fix this up and I'll post it, and then you can make your computer fan spin too. Now, here's something more. So instead of just mapping, if you think about map, you have inputs 1, 2, 3, 4, 4. And those will map across. If I'm squaring this, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. There's a 1-to-1 mapping. But I also want to reduce this to have one sum. So 16 plus 4, 9 plus 1, this will sum to 30. Oh, 30. That's called reducing. Mapping goes across. Reducing goes down, will shrink our data set down to one result. Now, reduce is passed 2 different elements. So the reduction will be the sum of these two, then the sum of these two. Those will sum to something. 16 plus 9 is going to be 27 plus 5. Is my sum wrong? 20, 30. Okay. 27 plus 5. Oh, 20. There you go. 25. Let's spread that as whatever. Shot problem. 25 plus 5 is 30. So there'll be a second stage reduction. And it will always do this one function down, 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 all the way down to one thing. Oh, that's I was talking about reduce. This is filter. We can filter. This is like slicing. I jumped ahead. Let's talk about reduce because that's where I'm at. 2 arguments returns 1. We do have to import something from functools. which is nice if your last name is Funk. Ooh, ah. I just got grumpy with me. So I'm going to make a new file, and I'm going to reduce something. So here's my functional tools. I'm going to have a list. I'm going to call my data is equal to list of range starting at 0 up to 10. 20. And I want to filter out any odds. So what I'm going to do, stealing this from my inputs, is instead of passing in a list, I have a list here of data. I can have a lambda function, which is again a lightweight function. And I want to, I'm reducing, now I'm filtering in my head. I want to do a summation. All I'd have to say is for any x and y, add them together. Okay. Boop. And that will be the sum total. I should print that out. And sure, 190 sounds about right. Now, if I wanted to do a filter, like what I was talking about, which is like slicing, I can get a, I just need this one. I want to filter out all my odds. And I want to do that before my sum. So what I'm going to do, instead of from the slides I said less than 0, I want to say if it's odd. So %2, if it's equal to 0, I'm going to keep it. Otherwise, I get rid of it. And this is just evens. So I'm slicing out odds. My number list is data. I'm going to print this out. Just events. This is filter, reduce, filter. Sure. My computer's really unhappy with me right now. You know what? They're spelled the same way. I don't care. So I have just evens. I'm sorry. And then I reduce it, and then my sum total. Let's actually reduce it and then do a sum on just evens or events because I'm dumb. There we go. It did a sum. It's a different way of thinking, and it actually runs quickly, which is neat. If you're doing this in JavaScript, it's frequent because trivial parallelization is important in JavaScript because when websites do it quickly, you'll see map done a lot in JavaScript. If you ever actually want to build a website, I don't know. So yeah, filter, whitelist filter, reduce will take two numbers and bring them down to one, and then repeat that process until there's just one number left, which is really neat. And here's an example. I can actually do this. It'd be fine. From a list of sales, how do we add tax to each item and then remove negatives to get the total? There can be a negative sale if somebody has returned. So we don't want returns. That's not useful to us. We can use this data set. That's fine. I will give my, you know, I'm just going to say demo and start from scratch. Demo. I want all my imports from here. I guess just reduce. I want to return the total, so that is what I'll be doing there. Map and filter are actually built in for free because that's how often they get used because they're cool. Okay, so I have my sales is equal to import random. Should I do NumPy? Yeah, I'm going to do NumPy. I want a list of random data. import NumPy as np. Sales is equal to np.randint. np.random.randint. I'm falling apart. And we're going to say from -10 up to 10. And I want to have 20 of them. 10 of them. Sure. I love it. Print sales. I'm going to set my seed because I actually want to have repeatable data. np.random.seed. You didn't see that one coming, did you? And there you go. I have a bunch of negative numbers. Now I want to apply tax. So with tax is equal to map And I'll have a lambda function, lambda x, and then x is equal to, is tax 12% right now? 1.12. And then I'm going to pass in my sales. And sales should be iteratable. If not, I will have to cast it to a list. And I'm going to print with tax. With tax. Boop. And it's a map object. That's why I have to call list on all of these. I don't know if you saw me doing that. That's why. I'm not happy about that. That's a Python 3 thing. There you go. That seems taxed. Great. Then I want to filter out negatives. No neg is equal to filter. I'm going to say lambda x. I can name this anything. It's a parameter to my function. If x is greater than 0, keep it. And pass in with tax data. And then I'm going to print out no neg. I could do this in either order. They would both be the same. I need to map. I need to pass that into a list. So it'll actually do the map for me. And I got nothing. They're not all negative. Why would that be? There's a bug here. I'm going to have to look at my own slides to figure out what it is. I'm going to pause because I don't feel like torturing you. It was about data types. So I'm glad I did that because that was weird. So I am now making it into a list right away. I print that out. I pass with tax into here. I filter out. I didn't actually change anything in my filter. Then there's no negatives. And then I want to reduce this down to one grand total. Total is equal to reduce. And then I can have that lambda function again. X and Y. I want to add any x, y's together and return them. And then I'm going to do the same thing here. I'm going to put this into a list because that is what busted me last time. And then I'm going to pass in the no negatives data. And then I'm going to print. I should be able to print total. That should just be an integer and it should be totally happy with me. 45, 42 and change. That seems right to me. Is this very different than the stuff that you've been writing? Probably. Is it short and beautiful? Yes. Is it fast? Also yes. Is it readable? No. Even I struggled there. I had to pause. I've paused like 3 times in this class. So yeah, that's hard. Filter out things that are more than 100. That's actually pretty tricky. We would, instead of writing a lambda function, we'd probably write our own function. But I can leave that to you to try. So Lambda, Spark, Map Filter, Reduce, very cool tools. Check out Spark if you want to do some high performance computing. It's amazing, but it's also not obvious, but it is cool. Anyway, that is something that some of you are going to totally jam on. The rest of you will hate, and that's okay. And this is it. This is my last thing. I'm going to make a little sign-off video because I've made lots, and I feel that I need to say goodbye later. So I hope you're having a good day. I'll talk to you later.